Hi guys, so today we're going to just take a look at some more verifying identities so that we can add strategies to the problems as we see them, right? So some more options on things to do is all. So after your homework, this might seem very fitting. Brace yourself, right? Trig identities are coming. All right, so for example, this one. And which side is more complicated, right? It's tough. They both have the same number of things on it, so it's really up to you. Which one would you rather work on? I'm going to choose the left side just because there's subtraction, okay? Make it look like the right side. All right. I guess the first thing I'll look at is this cosecant, and I want to rewrite that as 1 over sine. Just write it in terms of sine and or cosine. There's not much to do from there except for maybe get common denominators and try to add those two fractions. So this guy needs a sine x in the numerator and in the denominator. So if I multiply numerator and denominator by sine x, I get sine squared over sine x. I get common denominators with the purpose of combining these fractions, so I might as well go ahead and do that. Right? 1 minus sine squared is an identity, right? That gives me cosine squared. Now, I'm trying to get this to look like cosine x cotangent x. Sometimes writing it down helps. Okay, well, I know that. I can kind of factor out a cosine over here to the side. And if I do that, I'm left with cosine times cosine x over sine x. Well, cosine over sine is cotangent. And I know that I can do that because if I take cosine x times cosine over sine, I'm going to get back to cosine squared over sine. So it's definitely something I can do. Right? And so some of this inevitably gets you saying, well, I didn't know I could do that. Well, these are all just different properties that you haven't had to use this in this way before. So it's just some arithmetic, just some knowing what to do. And if you're thinking, there's no way I'm going to come up with that. Well, you don't have to now. Now that we've seen that you can pull a cosine down, use that for the next problem. Could help, right? All right. How I feel when I solve a trig identity, right? That's exactly the way it goes. Should be dancing in the streets, right? These are going to be can be tough, without a doubt. All right, next one. I'm definitely going to want to work on the left side. That looks incredibly crazy. And in order to do that, I need to get common denominators so that I can combine those two fractions. Right now they don't have common denominators. One's a 1 minus cosine, one's a 1 plus. So that means I have to multiply the left fraction with what it's missing, which is 1 plus cosine. The right side guy is missing 1 minus cosine. So now I've got to do some foiling, right? And yes, we can FOIL these guys just like we do any other binomial. Probably would be easier if I brought these down to C. So double distribute here. 1 times 1 is 1. 1 times cosine is cosine. Then we go cosine times 1, which is cosine. Cosine times cosine, which is cosine squared. Now, in the denominator, we get what's called a conjugate. We mentioned that last time. 1 minus cosine and 1 plus cosine are conjugates. And those are conjugates because when you double distribute here, you get 1 minus cosine x. Then we go plus cosine x minus cosine squared x. Then we go minus, and then we double distribute here. 1 times 1 is 1. 1 minus cosine is negative cosine. Then we go negative cosine times 1, which is negative cosine x. And then negative cosine times negative cosine is positive cosine squared x. Over. And then same thing down here. 1 times 1 is 1. 1 times cosine is positive cosine. Then we go negative cosine squared x. Okay, now combine like terms. Well, we got like terms here. So we go 1 plus 2 cosine x plus cosine squared x all over. Like terms here, but those guys are opposites. They're just going to add to 0. So we go 1 minus cosine squared x. So conjugates. There's a quick way to multiply conjugates. The idea that these middle terms are going to add out to 0 will always happen for conjugates. So you could just square the first guy, square the second guy, and throw a minus sign between them. We'll use that on the next one, just to try to make it a little bit shorter, a little bit easier. Okay? Over here, I got like terms. So combine those. So 1 minus 2 cosine x plus cosine squared x over. Those are like terms and give you 0. So keep in mind that we're trying to make this look like 4 cotangent x, and that's a cosecant x. Okay. Now, in order to combine these two fractions, we need to understand that when we subtract, we can change that subtraction to a plus sign, but just like our binomials from before, we have to change all the signs behind it in the numerator. And if we do that, we get 1 plus negative 1, which is 0. We get 2 cosine plus 2 cosine, which is 4 cosine. And then we get positive cosine squared, negative cosine squared, which is 0. And that's all going to be 1 over 1 minus cosine squared x. Well, we got a 4, so we're starting to look a little bit like what we're supposed to on the right side. In the denominator, you got 1 minus cosine squared. That feels like an identity because it is. We get 4 cosine x over sine squared x. And again, over on the right side, we're trying to get a cotangent and a cosecant. Cosecant is 1 over sine. Cotangent is cosine over sine. So we basically have that if we pull a sine squared out. Now, the sine squared is in a denominator. So I can make this 4 cosine over sine times 1 over sine. And this gives you your cosecant, this gives you your cotangent, and so we're basically done. Sorry about the small corner there, but that's it. Even in the denominator, you can factor that denominator out. Little crazy, but now that you've seen it, think about those conjugates. Sometimes they help a lot. Okay, if that doesn't make a ton of sense, make sure you come in and see me. Next one. Left side or right side? You might have a different opinion than what I would maybe want to do. Okay? But I want to choose the right side and work with it. It looks a little bit more complicated with the fraction and the minus sign. So, one of the hints in your notes from last time says if you see a 1 minus or 1 minus sign or 1 plus sign, actually it says if you see a 1 plus sign or 1 plus cosine, think about multiplying by the conjugate. That's what I want to do here. I want to multiply the numerator and the denominator by the conjugate. Remember, the conjugate is just different signs. So the conjugate for 1 minus sign is 1 plus sign. And again, the reason why I do that is I know that I have to double distribute these. And when I do, the outsides and the insides will give me opposites, which add to 0. So watch what happens. Distribute this cosine here. That's fine. Cosine x plus cosine x sine x. In the denominator, since those add to 0, all I got to do is do first times first, which is 1, last times last, which will give you negative sine squared x. Now, that's an identity. So we go cosine x plus cosine x sine x all over cosine squared. Now watch this. We have a numerator that has an addition in it, right? I can actually split this up into two fractions that have the same denominator. This is allowed. It's backwards from what we normally try to do, but there's a reason why I want to do it. If you look on the left-hand side, we've got a secant x plus a tangent x. That's what I'm trying to get to. And by doing this, I can divide one of these cosines out and be left with 1 over cosine, and then divide one of these cosines out and be left with sine x over cosine x. And that'll give me exactly what I'm looking for. 1 over cosine is secant. Sine over cosine is tangent. And that's exactly what I want. And how did I know to do that? Well, because I paid attention to the left side and tried to get the right side to look like the left side, which means I had to split that fraction up. And now that you've seen it, you need to take that with you and try to do it on your next problem, if it applies. Okay? Like, take a look at this one. Left side or right side? I would agree that the left side is a little bit more complicated looking, but I've already got conjugates on the right side. I don't know. Kind of thinking maybe we ought to do that. Yeah, I don't know. Maybe not. Someone change your mind and go left side. Doesn't really matter. Right in the end, it doesn't matter. But I'm going to work on the left side. And in order to do that, I'm going to rewrite this in terms of sine and cosine. So make this sine squared x over cosine squared x all over 1 over cosine squared x. Now, I'm going to flip this over and multiply. So I get cosine squared x over 1. That goes away. I'm going to divide these out. So I'm left with just sine squared x equals, and this is supposed to be 1 plus cosine x, 1 minus cosine x. How do I make those look the same? Well, again, I'm going to go backwards. I'm going to rewrite this a little bit more complicated than what it is right now. Sine squared I can get if I have 1 minus cosine squared x. And if you look, this is the result of two conjugates being multiplied together. This is what's called a difference of two squares. So I can factor that. I factor that into those conjugates. You square root the first guy, square root the second guy, and do a plus or minus. And if we do that, this looks just like the right-hand side. How did you know how to do that? Well, because I've done this before, right? How are you going to know to do that? Because you just saw it. And so factoring down like this could be helpful as well. It's all about gaining strategies to use for your future stuff. Okay? All right, last one. Can I pick up a strategy from this last one? I'm going to work on the left side again. Fraction and subtraction. Always more complicated. But from a couple problems ago, I realized that I can actually separate this into two fractions, which is helpful because I got two terms over here. So I can go tangent of x over sine x cosine x minus cotangent of x over sine x cosine of x. Okay? Now, I can rewrite tangent as sine x over cosine x all over sine x cosine x minus, this is cosine x over sine x all over sine x cosine x. Now, what to do here? Well, sine x cosine x is in this denominator. I can still make it a fraction and then use this whole flip and multiply strategy that I've done before. That's allowed. I've done it before. It's a little more complicated with two trig functions in that denominator, but that's okay. So this is going to go away. Now, over here, I can cross simplify. Divide out the signs, and I get 1 over cosine squared x minus, divide out the cosines, and get 1 over sine squared x. 1 over cosine squared is secant squared. 1 over sine squared is cosecant squared. That's exactly what I needed to end up with on the right side. So I'm done. Verified. So again, more strategies to take with you. Okay? All right. Hopefully that's enough to get you through the next homework. So give it a shot. We'll talk about it next time.